Good morning. Welcome to another session on environmental impact assessment. So let us move ahead in the introduction. So the course outcomes again. So describing the objectives, capability and limitations of EIA, learning outcomes for this particular session, the components of the environmental impact assessment, advantages and disadvantages of the EIA process in brief. Right. So specific outcomes, what are the list of the components and its explanation, benefits of EIA, drawbacks of EIA. So what are the components of EIA, right? So uh, there are two different types of EIA, right? So one is a comprehensive EIA, another one is a rapid EIA. So both of them vary in the time scale of the data that is being supplied. So rapid EIA is a speeder appraisal process, right? So rapid EIA achieves this through the collection of one season data, whichever is stressful for the project, only to reduce the time required, right? But this particular EIA is adopted only when you have to take a quick decision, right? Uh, and also it does not compromise on the quality of the decision making, right? So that is the rapid EIA process. The comprehensive EIA process is a one which takes a longer time, right? Maybe even 6 months time, or even 6 to 8 months time it takes for a comprehensive EIA. Rapid EIA is generally done in about 60, about 90 days time, right? Within 90 days time you have to make a decision. But the comprehensive EIA takes about 6 months or to 8 months also. So in the comprehensive EIA, what we do is we are not in a hurry to take a decision, right? So uh, the process goes in a gradual way, right? Where we collect data from data of different parameters, and we evaluate them, identify the impacts, and propose a mitigation plan, and environmental management plan, so on and so forth. So these are the two different types of EA process. We'll be looking at this again in the coming units, maybe in second or third unit. Again, we'll be looking at this thing in a little more elaborate manner. So for now, that is the difference between the comprehensive EA and the rapid EA. So rapid EA is done when some projects have to be done very quickly, and you may have to give a quick decision whether the green flag should be given for the project or not. So depending on the nature, location, and scale of the project EA report, right, they should contain some or all of these components. One is the air environment, noise, water, biological environment, land environment, socio-economic, health environment, risk assessment, and finally the environmental management plan, right? Um, so coming to the air environment, so we'll look at a little more in detail about each of these things, right? In the last session also we have seen something about the air, water, land, and the socio-economic aspects. So what we are really looking at in the air environment. So we are going to find out or determine the impact zone and develop a monitoring network, right, which will keep monitoring the air quality time to time. It may be every second, it may be every minute, it may be every hour, right? Monitoring of the existing status of the ambient air quality within the impacted region. For example, 7 to 10 kilometers from the periphery of the industry, how is the air quality that is going to get affected. So ambient means the something like which is existing in that particular location, that is called ambient. For example, when you're sitting in a room and you have some temperature within the room, that is the ambient condition, right? Well, when you go outside, step outside, maybe much more cooler, right? In the house or inside the room it may not be like that. So the ambient condition is what actually exists in a particular place where you are situated. Monitoring site-specific meteorological data, for example, you look at the wind speed, wind direction, humidity, and ambient temperature, and something called the environmental lapse rate. So why we see all these things? Why? Because when you have air pollution, uh, obviously it is going to travel, right? It's smoke that is coming outside from some industry, it is going to move into the air. It's going to travel into the air, and how fast it is going to travel into the air depends on the wind speed. It depends on the wind direction. It depends on the temperature that is going to be there, right? Estimation of the qualities of the air emission from the proposed site. So from the source itself, they'll have to monitor how much pollutants are being emitted into the atmosphere. Identification and quantification and evaluation of other potential emissions within the impact zone. So apart from this, there may be something else. You may have to quantify that. You have to identify that. You'll have to evaluate those things, those kind of emissions. Meaning, apart from the industry, you may have a lot of what do you say, traffic, for example. So, assuming that you got some industry and so many people are coming with vehicles for work, or you're transporting something from here to some place, and you're using a lot of vehicles, so that may be also causing some impact. So you may have to look at those things. Prediction of the changes in the ambient air quality through the air quality modeling. So generally, model is being used to predict something in the future without actually seeing what actually happens. For example, uh, it's impossible to build an industry and then practically see what happens to the air quality over time, right? It may be a catastrophe, meaning it may be really bad, because industry may be generating a lot of pollutants, and in the first place, you shouldn't have constructed the industry. So we cannot know things after constructing something, and then later feel bad about it. So what they do is they have something called the air quality model, and in the air quality model, what you can do is you can give the amount of pollutants that will be generated, and you can give the wind speed, the ambient temperature, wind direction, humidity, and all these parameters will be taken into account, and you can see where the smoke is going to move, whether it is going to move towards the residential areas, or it's going to move towards maybe an isolated location. Or where is it actually going? So that can be seen in the air quality modeling. Evaluation of the adequacy of the proposed pollution control devices, right? So to control this air pollution, generally they'll have some devices, right, to control them or to reduce uh, this pollution that is being generated. Actually, what they have to do is, for example, the industries that are emitting a lot of smoke into the atmosphere, they are supposed to have some particular filters depending on the particulate matter or particulate size of the pollutants that is coming out. They may have to have a particular type of filter which will filter out all those pollutants, and then the clean air is being released into the atmosphere. So the adequacy of that and the evaluation has to be done for those things, right? Whether they meet the standards. And the thing is, like, generally what they do is the particular filter may not be a permanent one. Cannot have a lifelong filter that will work for the entire uh, history or something like that. So you may have to replace it. You may have to replace it then and there, right? You will have to replace those filters. So in that case, when often it has to be replaced, or how often it has to be replaced, and so on. Delineation of mitigation measures at the source, pathway, and receptors. So delineation means you have to chop out, you'll have to frame the measures for overcoming this at the source, that is the place where the smoke is being emitted, the pathway, something happening along the movement area, and receptor, people are receiving it, for example, they are inhaling the smoke. So what you can do to stop them from prevent them from inhaling the smoke. So you'll have to look at the source, you'll have to look at the pathway, you'll have to look at the receptors. Noise environment, monitoring the present state of the noise levels within the zone, predicting the future noise levels that is going to come because of this project, because some industries will create lot of noise, right, due to the movement of the machinery and so on. And you may have some vehicular movements, so a lot of cars and buses are going to fly around, and that will create a lot of noise. Identification of the impacts due to an anticipated rise in noise levels on the surrounding environment, so what kind of impact it is going to have on the people there, and the recommendation of mitigation measures to overcome the noise pollution, right? So before we end this session, we have a quiz. The following environmental parameters should be considered in the EA process: air, water, land, and option D is all of the above. Thank you. Thus, we come to the end of this session. Thank you for your participation. Looking forward to meeting you in the next session.